So there's this exercise. There's a bode diagram to be made from the given transfer function. So the first step to doing this is getting the poles and zeros from this equation. So to get them, in this case, it's already like mostly prepared. So it's just possible to read out that the poles here are from the top, taken from the top. So say there's this exercise for sketching a bode diagram with a given function. So the first step to making a bode diagram like this is finding all the poles and zeros of the diagram. This can just be read in this case from the formula. So usually you might need to change a few things in the formula, but in this case it can just be read out here. The zeros are on top, and at the bottom there are the poles. The way this could be remembered is that if the top of the equation goes to 0, then you know that the entire equation is becoming 0. While if something at the bottom is becoming 0, the entire equation is probably going somewhere into infinity, maybe minus infinity, no one knows. Either way, the zeros are thus, in this case, s tau minus s tau 1 and minus s tau 2, while the poles here, they are s tau a minus and minus s tau b. So usually these values will be given some kind of arbitrary value, but this time there's no value yet. So for this exercise, we're gonna assume that tau 1 is gonna be the smallest, tau 2 a bit bigger, tau a bit bigger, and tau b a bit bigger. This will be crucial in some later exercises here. Then, with these, it is possible to put them into the diagram with the real and imaginary axis. This isn't yet a bode plot, but this is a good way of just showing where these points might be laying. So tau b is said to be the biggest one out of these. So it could be, you could put tau b right over here somewhere. This is if we are assuming tau b to be a real value. However, say if we'd also have tau c, which would, for example, like be a plus minus bj, or I, if you're not an electrical engineer, and then it would, for example, c, I'm going to make c orange, then c would have poles both on the top and bottom balanced out. They're always balanced, pretty much like they're never found unbalanced. They're either on the axis or balanced. However, these are exactly on the real axis, as they don't have any complex parts in them. So this can just be, but that is the same with the other ones, with minus tau a minus tau, or rather, and after that the bode plots themselves can be drawn, where this plot is gonna be along omega, and this one is for the base. It goes from 90 degrees to minus 90, or rather in this case it actually goes till 180 and minus 180. Sometimes it's... and then we can put these points onto here. So whenever there's a pole on here, it can be assumed. So then, to draw them, for every 0, it can be assumed that there's a 20 decibel per decade gain, while for every pole there's gonna be a 20 decibels per decade drop. What this means is that if you put them down, which in this case will pretty much mean putting down 1 divided by them, it'll mean that initially it would be going straight, but then starting from this point it's actually going down with a slope of 20 decibels per decade, as this is the first pole. Then, in the correct order, there's the next one, 1 tau a. The correct order is because of this right here. As we set these values to be like this, they are going to be in this order. And next up, followed by 1 tau 2, and 1, tau, 1. When there's another pole, this will mean that it is going to further decrease by 20 decibels more per decade. Then the 0 will cause it to start going down less, and here it's flat once again. However, the actual plot itself isn't composed of straight lines. It's actually more just a smooth, in the correct place, but it's just a smoother line through this, without any angles here and here and there. Next up, there's the angle plot. A similar situation is also the case with the angular plot. So basically, whenever there's a 0 in this plot, it's going to go by 90 degrees up. Well, for every pole, it's going to go 90 degrees down. So what this means is that we can assume that it just begins at 0, and then around here, it'll go down by 90 degrees here again, and then back up. Again, it's going to be smooth, where we can just assume that it just goes through the 45 degrees points around here. So it'll just go, wow, just through all these points. So this is pretty much how to draw these body plots if a function is given like this. Usually though, you'll need to begin by actually getting these zeros and poles out of the equation though.